Good evening, students. Welcome to our learning channel of mathematics. In previous video, we are covering under operations of matrices. Topic 2, I covered how to find the determinant of a square matrix, which is mainly required condition to find a power minus 1 or a inverse or multiplicative inverse of a square matrix A. So to find inverse of A, that get A value whatever explained in the previous video should not be equal to 0, not equal to 0. And one more requirement for the inverse is that adjoint of a square matrix. So in short form, it is written as ADJ of A. Adjoint of A. How to find this? That we can discuss today. Once these two are ready with you, then computing of A inverse becomes easy. Let us consider a square matrix of our choice. So I considered a square matrix of size 3 by 3 to find out adjoint of this matrix. Adjoint of this matrix, how to find? So there are two ways using the theoretical procedure where we need to find out cofactors of every element. Other is that a shortcut method to get the adjoint matrix. I would like to explain both of them so that students can feel comfortable which they can apply to find that adjoint of the matrix A. Let us see that general method to find out the adjoint of this matrix. This terminology, cofactors of elements of capital A. For each of the element, we need to find out cofactors. To find determinant, we take their minors of any one row or any column, excluding diagonal elements. To find out the adjoint of the matrix, we need to find out cofactors for all the 9 elements. Either row wise you prefer or column wise. Let us continue how to find out. This is how we need to compute the cofactors for every element of matrix A. So I prefer row wise. First row, we write a cofactor for the first element as C11. C11 means cofactor of this element A11, that is equal to minus 1. You have to add the subscripts here, 1 plus 1, row number plus column number, into this already been covered. M11 stands for minor of that element. So what you are going to get here, minus 1 power 2, and a minor of first element will be obtained by deleting first row, first column. Deleting first row, first column, we need to take the remaining elements -1, 7, 5, 6. This is equal to minus 1 to the power of even number 2, 4, 6, 8 is always gives you plus value, or plus 1 we can write, plus 1. This already you know how to compute. You can remember like this, left diagonal product, LDP, left diagonal product minus right diagonal product, LDP minus RDP rule. I am avoiding the arrows to avoid confusion there. LDP, left diagonal product minus right diagonal product. LDP means this into this. You square bracket when you find the depth of a 2 by 2 matrix there. So we get here minus 1 into 6, it is -6. minus 5 into 7, 35. Direct line computing, this value is equal to plus 1 into minus 41. Minus plus is negative 41 we get. Negative 41. Next move to next number C12. It is a cofactor of first row second column element. You can write minus 1, add the row number 1, column number 2 into its corresponding minor M12. So we are going to get negative 1 to the power of odd number 3 we get. Here the minor M12 is obtained by deleting first row second column. First row second column. So we get 0, 7, 3, 6, 3, 6. This is equal to minus 1 to the power of odd number. Multiplying minus 1 3 times, we get negative 1. Square bracket. 0 into 6. Same. LDP minus RDP rule. 0 minus 21. This will be equal to negative 1 times negative 21, that is equal to plus 21 or simply 21. So it is continuation. C13 cofactor of first row third column. Same way it is being worked out here. Minus 1 to the power of row number plus column number 1 plus 3 into its corresponding minor M13. Minus 1 to the power of 4. Deleting first row third column. First row third column. Leftover elements there. Then apply LDP minus RDP rule. It is minus 1 to the power of 4 means multiplying minus 1 4 times, we get plus 1, square bracket, 0 into 5 0, minus 3 into negative 1 is minus 3. Using arithmetic operations there, plus 1 into 3 we get 3. C21 similarly minus 1 to the power of 2 plus 1 into corresponding minor M21, minus 1 to the power of 3. Deleting second row first column, second row first column, 4 2 5 6, 4 2 5 6, minus 1 multiplying 3 times we get negative 1. Applying LDP minus RDP rule, 6 into 4 24 minus 5 into 2 10. So negative 1 into 14 is equal to negative 14. Yes. So the remaining cofactors have been computed. C22 minus 1 power 2 plus 2 into its corresponding minor M22, minus 1 to the power of 4, deleting second row second column 1 2 3 6, minus 1 to the power of even number plus 1 we get, or minus 1 multiplying 4 times we get plus 1 into LDP minus RDP rule, 6 minus 6 0, plus 1 to 0 0. C23 the same way we got 7. C31 we got 3030. C32 we got negative 7. C33 we got negative 1. After finding the corresponding cofactors of every element, moving row wise, row 1, row 2, row 3, then we need to write down all these entries, what all you got, the cofactor values, by using a matrix called cofactor matrix. Let us conclude that adjoint of the matrix capital A. So the cofactor matrix of given matrix A is given by writing corresponding cofactors of the elements, what all you found out just now, by giving the letter C there, capital C, row wise. First row, second row, third row. These elements we got the results, cofactors. Then adjoint of the matrix is given by taking transpose of this cofactor matrix. I wrote C power T, transpose of C. Therefore, adjoint of the given matrix is given by, you write each row as column. First row becomes first column here. Second row becomes second column here. Third row, third column. This is the theoretical method or the long method to find out adjoint of a given square matrix. Now, next I am going to cover short method to find out adjoint of the square matrix without finding cofactors. Directly we can give the answer by using that shortcut method. In examinations, students can make use of this. So instead of finding cofactors of all elements, what I explained just now, it is a shortcut method or approach we can say to compute the adjoint of a given square matrix. Here I took a different example, a 3 by 3 matrix. I have given the notations for row 1, row 2, row 3, C1, C2, C3 as we discussed in the previous very last video, right? So first, what is this arrangement? How you are going to get? You see that blue color indications R1, R2, R3, R1, R2, R3, C1, C2, C3, C1, C2, C3. As it is, the elements being copied in black color. 1, 2, 1, 2, negative 1, 0, 1, 3, 4. This is just the matrix elements have been copied there. Next, you see the green color indication R1, R2. You have to copy previous R1 and R2 as it is 1, 2, 1, 1, 2, 1. R2, 2, negative 1, 0, 2, negative 1, 0. Over. Now come back to that side. Red color indication. We have to copy column 1 under blue, column 2 under blue. 1, 2, 1, 1, 2. 1, 2, 1, 1, 2. C2, 2, negative 1, 3, 2, negative 1. 2, negative 1, 3, 2, negative 1. Hope this structure is clear to you. This is the setup to be maintained. Now, what is to be done? You delete row 1 and column 1 completely. Now, you are going to find out here some elements. 1, 2, 3, 4. 1, 2, 3, 4. 16 elements are there. Now we are going to generate 9 elements of the adjoint matrix of capital A. That is possible only by taking 4 elements and applying LDP minus RDP rule. This 4 LDP minus RDP. This 4 LDP minus RDP. This 4 LDP minus RDP. We get 3 elements in first row. Next, this 4 overlapping LDP minus RDP. This 4 LDP minus RDP. This 4 LDP minus RDP. We get second row elements 3. This 4 LDP minus RDP. This 4 LDP minus RDP. And last, these 4 LDP minus RDP. If you apply carefully, all the 9 elements will be getting easily. Let us see. I am going to write down the result of this adjoint here itself by the way I explained just now. So it will save time instead of finding all the cofactors. Let us compute the adjoint of the matrix by following this method. So let us compute that adjoint of the matrix directly from that LDP minus RDP rule, applying for 4 elements under consideration. So here we can write directly adjoint of A. Now how to write the elements? That is the most important thing, because in the previous general method we have found out all the cofactors, 9 cofactors of each element. We place them in a separate matrix called cofactor matrix denoted by capital C. Then we took the transpose of it. So avoiding these two, here only we can write down the adjoint of A as below. So first you proceed applying LDP minus RDP rule by taking 4 elements row wise. You write the result column wise. That is the idea here. So first element of adjoint A. So apply for these 4 elements LDP minus RDP rule. Left diagonal product minus right diagonal product. 4 into negative 1, it is negative 4. Minus 3 into 0, it is 0. So negative 4 minus 0, we get negative 4. So I will indicate here, I am moving row wise here, but here I'm going to write down column wise. Next element, take this 4, 0 minus 8, it is negative 8. Next, these 4, 6 minus of minus 1 plus 1, 7 over. Next, come to this part. What will happen? Take these 4 elements, 3 minus 8, it is negative 5. Next, these 4, 4 minus 1, it is positive 3. These 4, 2 minus 3, negative 1. Now take the third part. Calculate the elements row wise here, write them column wise. Same procedure. 0 plus 1, it is 1. 2 minus 0, it is 2. And last, negative 1, negative 4, it is negative 5. This is the required adjoint of A. So here we can save time when compared to general method. So I would like to give you an example problem for you to solve or compute. Let B, I will take B matrix here, 7, 6, 3, 2, negative 1, 0, 1, 4, 2. Your task is that compute adjoint of that matrix by using the general method and as well as the short method what I explained to you. So in this video, we covered how to compute the adjoint of the matrix by using length method or general method and also shortcut method. In next video, I'm going to cover how to find the inverse, multiplicative inverse of a given square matrix. Do subscribe and share to your friends so that learning never stops from your side. All the best.